Our next topic is uniformly accelerated motion, where we follow the three kinematics equation. Now, how do we use this equation? So we have here an example. A car is going 8 meters per second on an access road into a highway and then accelerates at 1.8 meters per second squared for 7.2 seconds. How fast is it then going? So first, let's look for the given. The given here is the first one. This one. This is per second. If you see something that meters per second, that is actually automatically the velocity. Okay. If you see something like this, meters per second squared, that is actually automatically the acceleration. And of course, this one is just 7.2 seconds. That will be my time. Now, how fast it is going? Remember, if there is accelerated motion, that means the velocity changes. So this will be your initial velocity. And then we will look for the final velocity. We have the following given. Okay. Now, as you can see, I have 1, 2, 3, 4. So I'm looking for V. So I have V here. I have V here. I don't have V here, so I will not use this. The next one, I have V naught A and T. I have V naught A and T, but I don't have the X. So I don't have this, so I cannot use this one. I am left with this equation. So therefore, if I use that, I substitute the values and I will have this answer. 20.96 or approximately 21 meters per second. The next one. Now, again, let's look for the given. A 4 meters per second is obviously the velocity. The next one is the 5 meters per second squared. That is meters per second squared. That is obviously the acceleration. And next, this is the time. But let's look for the required. It's how far. So we are actually looking for the change in x. Remember, the change in x, guys, is the final distance with the initial distance. If it started with 0, therefore, x is just equal to the change in x. So we have this one. This is the required. So these are the given. Now we are required to look for this one. That means we are looking for this, we are looking for this. And that's not available on the first equation, so we're not going to use that. The next step is look for something that you will just substitute and you'll get the answer. Here, we don't have a value of this one, so we cannot use this equation. We can use the second one. And then, so that's the second equation. You just substitute the values and you will have the answer. 64 meters per second. The next one. A car is going 12 meters per second. How long will it take to reach a speed of 26 meters per second if it accelerates at 2.2 meters per second squared? So obviously this is the acceleration. The next one, 12 meters per second, and the 26 meters per second. 26 meters per second. This will be your initial velocity. Again, if it accelerates, the velocity changes. This is your initial velocity and this is your final velocity. Let's write the given. So we have the following given. And we are now looking for the time. The time says how long. So we are looking for the time. Now, let's look at the equations. We are looking for the time. Here, we have time. We have time. Here, we have time. So, this is not part. We don't have this one. So, this is not the right equation. Therefore, we'll use the first equation. Now, if you plan to use the first equation, you can modify it this way. Plus 80. Let's move it to the other side. V minus V naught is equal to 80 divided by A divided by A. Cancel, cancel. So you have time is over A. So that's why we have this equation. And then if you substitute all of the given, you will have 6.4 seconds. Now let's go to example number 9. How far does a car travel in speeding up from 44.5 meters per second to 22 meters per second if its acceleration is 3.6 meters per second squared? Now let's write the given again. Per second to 22 meters per second. So if you see meters per second, this is your initial velocity, meters per second. This is your final velocity, meters per second. Acceleration, meters per second squared. It is looking for how far. So we are actually looking for this one. So let's write the given. And let's review again. We are looking for this one. We're looking for this one. So we're not going to use this. We don't have time. We don't have time, so we cannot use this. We will be using the third equation. Now, if you are looking for the distance using the third equation, always modify the formula, or you can modify the formula later as you solve. I'll just modify it now. Now, for this one, I am looking for the x, so I'll just move. Divided by 2a, divided by 2a. Guys, the delta x is equal to the x minus x naught, but it started from a certain point at 0, so that's why they are just equal, in case you're wondering. So we have this equation for representing the x value. So let's just use that formula. This formula, you substitute the values, and then you'll have this answer, 64 meters. Number 10. A car going 19 meters per second jumps on its brake, slowing down to 8.4 meters per second and leaving skid marks 24.6 meters long. What was its acceleration? So we have here 19 meters per second. And then it slows down per second. So this is our velocity, our another velocity, and meters long will be our x. Now it's looking for the acceleration, acceleration A. Now let's write the given. Okay. Now let's review the kinematics equation. We are looking for A, so we have A here. We have A. We have A. Now let's check the given. We don't have time. We don't have time, guys. Wala tayong time. No time. No time too. So we are left with the third formula. So let's just modify that. V squared is equal to V naught squared, the initial velocity, plus 2a change in x. Or simply, I can write that as x. Now, I'll just modify it further. And that's divided by 2x is equal to a. So I will use this formula. So if I use that formula, I will just substitute the given values and I will have an acceleration of negative 5.9 meters per second squared.